In this video we'll be performing a famous condensation reaction between an aromatic aldehyde and nitroalkene called the Henry reaction. We'll be using vanillin and nitroethane and condensing these together to synthesize the 2-nitropropane compound. Start by weighing out 5 grams of dry vanillin crystals. Note that there are many different ways to perform this reaction, and if you want to use a different aldehyde or nitroalkane, then you'll need to do some research and hunt out the best way. Next, weigh out 2 grams of anhydrous ammonium acetate crystals. These must be anhydrous. Do not attempt to evaporate the mixture of aqueous ammonia and acetic acid. Unfortunately, it will not work. Ammonium acetate is hygroscopic, so keep this wrapped up to stop it absorbing moisture. Measure out 3.5 grams of nitroethane. Check out our other video linked here for details about how this can be synthesized. First, add the vanillin to the nitroethane in a 100 ml flask. You'll immediately see a slight yellow color being produced. Next, add the anhydrous ammonium acetate. You can see the yellow color becoming more intense. This is our reaction starting. Now measure out 10 ml of glacial acetic acid. This will act as a solvent for the reaction. Add this to the flask. The smoke produced is just some volatile ammonia from our catalyst reacting with the acetic acid. Give the mixture a good stir. Most of the solids should dissolve. Cover the top of the flask with plastic wrap. We could now simply reflux the mixture, but since we're doing this on a small scale, we'll do something a bit more cool. Place the flask into a microwave oven. We're using a regular kitchen microwave here. Now microwave it in short bursts at 100 watts low power. You want to get the liquid hot, but not boiling. After the first 30-second burst, the solids have dissolved and the liquid is turning an orange color. We allowed the flask to cool slightly and then placed back into the microwave. There's a little bit of reflux in the flask, but no actual boiling occurring. This is what we want. We gave the flask about 7 minutes of total microwave exposure time over about a 30-minute period. Here's our flask at the end of the reaction. Too much red color means impurities such as timers forming. Let this rest for a few minutes, but don't allow to cool. Prepare 35 grams of ice in a beaker. Now add the reaction mixture to this. Stir the mixture well, and wash out the reaction flask with 10 ml of cold water, adding this to the beaker. The oil present in the mixture should pretty rapidly crystallize into a yellow precipitate. You can see lots of crystals where we scratched the glass. We allowed the crystalline precipitate to settle, and then set up for filtration. We wash the beaker and the precipitate with 20 ml of cold water. And got the crude product as dry as we could using the filter pump. Here's our crude product: 3.2 grams of a yellow crystalline solid with only a very faint aroma of vanillin. This is a slightly disappointing 47% yield, So either we needed to use a bit more time in the microwave, or perhaps this is best done using a slow reflux. We recrystallized this using the mixture of 40% water in 60% methanol by volume. It took about 25 mL of hot solvent to get all the crude product to dissolve. On cooling, as the product crystallized out of the solution, some amazing patterns were seen dancing in the liquid. The mixture was then chilled down for 30 minutes to allow everything to crystallize out. The crystals were really beautiful, as you can see. These were filtered off and dried with 20 mL of cold water, then allowed to dry thoroughly on the pump. And here's our purified product. 2.8 grams of the vanillin nitroethane condensation and elimination product. This compound is relatively unstable and you'll need to keep it in the freezer if you want to store it for more than a day or two. It decomposes readily in contact with warm water to produce red-colored decomposition products.